Hello everyone, welcome back to physics online classes for class 12 students. Let us continue chapter 3, current electricity. Today we are going to study about Ohm's law applied to the circuit. In the previous class we studied in detail about cell, EMF, internal resistance and terminal voltage. So before going to start today's session, let us revise once again what we have studied in the previous class. Yes, what is a cell? A cell is a device which converts chemical energy into electrical energy. Then second point, what is EMF? Electromotive force. Potential difference between two terminals of a cell when the circuit is open or when the current is not drawn from it. Then third point, internal resistance. This is the resistance or the opposition offered to the flow of current by the cell. When the cell opposes the path of the flow of current, then we can call it as internal resistance. Then fourth point, terminal voltage. This is the potential difference across the terminals of the battery when the circuit is closed. When the current is drawn from it, then we can call it as terminal voltage. So now let us start Ohm's law applied to a circuit. You can observe this circuit diagram. We are going to consider a battery or a cell. This is E indicates EMF of the cell. Small r indicates internal resistance of a cell. This cell is connected to resistor R. This is external resistance R. Now here the current I is flowing throughout the circuit. Now we are going to consider capital V as potential difference across the resistor R. And small v we are going to consider here. I am going to draw that resistor, internal resistor here, but it is actually inside the cell. So let us take this is internal resistor. So potential difference across R is small v. Now I am going to consider the law of conservation of energy. What it states, law of conservation of energy? According to this law, we know that energy can neither be created nor be destroyed, but one form of energy can be converted into another form. Here, by using a cell, we are going to convert chemical energy into electrical energy. Now, EMF of the cell is equal to EMF of the cell is equal to, I am going to write potential difference across R plus potential difference across internal resistance small r. So why we are going to write the equation like this? You can observe EMF of the cell, it is denoted by E. E is equal to, this is equal to sum of potential difference across external resistor and potential difference across internal resistor. That gives EMF of the cell. Because we already studied in the previous class, EMF of the cell, for example, when we purchase the cell, EMF is how much? 12 volt. When the same cell starts to use, when it is doing work, then its value decreases. Why its value decreases? Because of internal resistance. So we can consider potential difference across R plus potential difference across internal resistor, that gives total EMF. For example, in the previous class we considered 12 volt. 12 volt is what? EMF. But here potential difference across R we got 8 volt and potential difference across internal resistor we got 4 volt. So again we will get the 12 volt. So before using EMF is 12 when the circuit is closed, but in reality we are getting only 8 volt. That remaining 4 volt is not destroyed. According to law of conservation of energy, it is not destroyed, but it is all because of this internal resistance. So here also we can write E equal to, so this is capital V plus this is small v. Let us take it as equation number 1, or we can write here in EMF E equal to, in place of V I am going to write I capital R plus in place of small v we can write I small r according to Ohm's law. Or this equation can be written as E equal to I is common, take outside, remaining is capital R plus small r. So we want electric current. So we can write I equal to E divided by R plus R. So this is an expression for electric current using Ohm's law. Let us take it as equation number 2. So here I indicates electric current throughout the circuit. E is EMF of a cell. Capital R is external resistor. Small r is internal resistance or resistance of a cell. What is the final equation? I equal to E divided by R plus R, or we can write I indicates current through the circuit is equal to E indicates EMF of the cell divided by R plus R. That means external resistance plus internal resistance. External resistance plus internal resistance. So this is what we applied Ohm's law. So we got electric current I equal to E divided by R plus R. Let us take it as equation number 2. Now I am going to consider some important note points you can observe. I am going to consider first case, that is from equation 1. See here, what is equation 1? E equal to V plus V. E equal to V plus V. So this is capital V. Or we can write E equal to V plus small v means what here? I into small r. Or I am going to write E. I can take this V to LHS side. E minus V equal to IR. I want internal resistor. So I can write R equal to E minus V divided by I. Right? Or I can also modify this equation as R equal to E minus V divided by I means what? I equal to V divided by R. So in place of I, we can write V divided by R. Then I am going to write the final equation as R equal to, see here, E minus V divided by V, R we can take to numerator, or R equal to, separately we can divide V here, E by V minus 1 into R. So this is an expression for internal resistance. What is the expression for internal resistance? R equal to E by V minus 1 into R. Right? Then I am going to consider second point, that is again from equation 1. What is equation 1? E equal to capital V plus small v. E equal to, I can write V plus, in place of small v, I can again write IR, or V equal to E minus IR. Suppose if I is equal to 0, what happens? If I equal to 0, then the above equation becomes V equal to E. You can observe, when no current is drawn, then terminal voltage and EMF both are equal when no current is drawn, because current is equal to 0. Let us take it as case A from the second point. So we considered if I equal to 0, we got V equal to E. That means the EMF of a cell, can also be defined as the potential difference across the terminals, the terminals of a cell when the cell is in open circuit. What I wrote here, the EMF of a cell can also be defined as the potential difference across the terminals of a cell when the cell is in open circuit, V equal to E. This is in the second point, first case. I am going to consider point B here only. You can observe. Suppose if R is equal to 0, if internal resistance is 0, then we can get the equation. You can observe here. Let us take it as equation number 3. In equation number 3, suppose if R equal to 0, again we can get the answer V equal to E. If internal resistance is 0, then V equal to E. So this condition we can get, or this is true only for an ideal cell. This is true only for an ideal cell. Practically, we will not get any ideal cell. There is at least a minimum internal resistance in a cell. So, V equal to E we can get only for ideal cell. Right? Then, come to the third point. I am going to write the flow of current inside the cell through its electrolyte is due to flow of ions. The flow of current inside the cell, it is all because of what? Flow of ion. Because we know that electrolytic solution contains large number of ions. Because of these ions, the flow of current takes place inside the cell. Then last point I am going to write here, the flow of current outside the cell. The flow of current outside the cell means externally, outside the cell through the external circuit. Through the external circuit is due to flow of free electrons. Because we know that externally it is connected to any connecting wire, it contains large number of free electrons. Because of these free electrons, so we can get electric current. But inside the cell, because of large number of ions in the electrolytic solution, we will get the electric current. So these 4 points you have to remember when Ohm's law is applied to electric circuit. Is it clear? So what is the first point? So suppose if I am going to consider equation 1, so we can easily get the internal resistance R equal to E by V minus 1 into R. Then second point in the second note, so when current is 0, we will get V equal to E, that indicates EMF of a cell. This is equivalent to terminal voltage when the circuit is open. So that means I equal to 0. Suppose internal resistance is equal to 0, then V equal to E. This is true only for ideal cell, but practically we will not get any ideal cell. At least minimum amount of internal resistance is present in a cell. Then third point, the flow of current inside the cell through its electrolyte is due to flow of ions. Similarly, last point, the flow of current outside the cell through the external circuit is due to flow of free electrons. So this is all about Ohm's law applied to the electric circuit. So in the next class, we can derive about the cells connected in series and parallel. To understand those derivation, you should be very clear with these concepts: cell, EMF, internal resistance and terminal voltage. So we can continue in the next class.